and welcome. Just as promised, today I'm going to take care of this 386 mainboard. It was heavily damaged by leaking battery and I'm quite confident that it is dead. I didn't try to turn it on because it is very oxidized and electrical current could make it even worse. So first, I will have to neutralize and clean all the green gunk from the traces. The battery was already removed, now let's desolder everything around the battery mount holes, what is in the way and potentially hiding oxidized traces underneath. The keyboard connector is pretty much ready for the trash, I will replace it by a new one. This is how it looks so far. The oxidized traces are very fragile, so I never tend to remove all the parts and try to leave some of them, which in my opinion could be still okay and are not necessary to remove. If such parts will make troubles later, I still will be able to remove them. Some traces were already completely rotten away. As I removed the ISO slot, I also saw this broken trace. This one goes from here to all of the ISO slots below, so overlooking this would mean that all the ISO slots would be dead. That's why it is important to look under every suspicious part. This broken trace and pad was not visible under the ISO slot from above at all. Okay, time for some white vinegar. If you don't know why I'm doing this, watch my other video about battery electrolyte neutralization. As you can see, the oxidation is on the backside just as bad, so to keep vinegar directly on the PCB from both sides, I use a thick paper towel wrapped around the board. This way, the spilled white vinegar will drain through the holes on the PCB and will be soaked by the paper towel from the other side. Left like this, wrapped into drained paper towel for about 20 minutes, vinegar should have enough time to get into all the small holes and neutralize the electrolyte. After that, the mainboard must be washed with soap and water. Doing this, don't forget to wash it properly with a lot of clean water afterwards and let the board dry in a warm, dry place for about 24 hours. So, now the traces can be cleaned from the oxide. I'm using a Dremel with some fine polishing tools. I found it to be the most efficient and gentle way of doing this. Fiberglass pencil is definitely worse for the PCB as well as for your fingers. Doing such work, please never forget to wear a mask. The fine dust is for sure not very healthy to breathe in. Unfortunately, some traces were damaged too much by the electrolyte. Some parts vanished completely and must be restored. I am using some wire and a lot of solder along all the traces. This will not only give back the continuity, but also restore the thickness needed to stand the required current. The corroded traces were already very weakened, so soldered wires on top could be easily ripped from the board again. To give it some additional strength and protection, I'll cover them with multiple layers of nail polish which I've stolen from my wife. So should I stop doing videos one day and vanish without any trace, that's probably because she found it out. Okay, time to put all the parts back. The AT power connector was partially corroded. I have no replacement, but I have another corroded connector where I could take 2 pins out. You see, 2 of them look slightly silvery, where all the other are golden, that's why. I replaced the corroded keyboard connector by a new one. Yeah, and this is the result so far. Looks quite good if you ask me. I left the jumper wire on the back side since I don't know what this is for, but I guess the one who made it knew why this was needed. Now let's check the continuity on the second pin of the ISO bus, which was restored previously. This looks very well. We have continuity to the chipset. I already tested the board for shorts and it looks good, so time for the first run. Aha, and as you hopefully can see, some numbers are running on the postcard analyzer. This means at least that the board seems to be alive, at least to some extent. Let's add some memory and add a PC speaker. Yay! 1 long and 8 short beeps. That means that everything is initialized, but the graphics card is missing. Let's add one. The main board still complains about missing video card. Let's test another one. I will try this 8-bit CGA card. Aha! Can you hear the memory check ticks? Means the card was detected. Let's try another 16-bit card, Zank ET4000. This one seems also not to work. Okay, next try this card can work as 16 as well as 8-bit with auto detect. Let's see if this one works. And it does indeed. I have a feeling that it has something to do with 16 versus 8-bit. Okay, since the 8-bit cards do work, let's concentrate on the 16-bit part of the ISO slot. What can we use to test it? Well, you don't always need an expensive oscilloscope. Sometimes such a logic probe for a couple of euros is more than enough. It lights up red when there is a logical 1 in the pin you are touching, or it lights up green if there is a logical 0. If there is a pulsation of signals between logical 1 and 0, the yellow LED lights up. So let's test the signals. Let's start with data pins. Data 15, 14, 13, 12, 11, 10, 9, 8, pulsing everywhere. This pin is memory write signal, which is low active, so logical 1 is perfectly fine. This is memory read is pulsing, which means it is trying to read something all the time. This is address line 17 pulsing, 18 pulsing, 19 pulsing, 20 pulsing, 21 pulsing, 22 pulsing, 23. Look at that. It is high all the time. This one should actually pulse as well. The data and address lines are usually connected to the CPU through a bus transceiver 74LS245. See it as a signal amplifier with an ability to detach the bus. Anyway, let's search the related bus transceiver. This can be easily done using a multimeter by switching into continuation mode and touching one of the related address lines with one end and going over the legs of suspicious bus transceiver with another end of the multimeter. And as you see, this one down here is the related 74LS245. As you can see, the address line 22 goes directly to the transceiver as well as our problematic address line 23. Okay, this is definitely the transceiver we are searching for. Let's desolder and test it. The traces here are very tightly packed, so to avoid too much damage, always add some fresh solder. Also using a heat gun a little bit can help. Let's see what the Am386DX says about this IC. And it seems to be good. Okay, how does a transceiver work? Simplified, it just puts to the output what it has on the input. So let's check the inputs. And would you look at that? During all the other inputs are pulsing, the one which is actually the address line 23 is neither 0 nor 1. It is dead. It is disconnected from any circuits if you want so. Actually, this pin should be directly connected to the CPU, so either the CPU is damaged or the trace somewhere between this pin and the CPU. Okay, I looked into the datasheets for the 386DX CPU and found that this pin is our address line 23. The socket has one-to-one connection to the onboard CPU up there. I checked the connection with multimeter and it is connected. Also, if I turn on the system, you can see the address line 23 pulsing here. So the connection somewhere between the CPU or CPU socket and the transceiver got lost. After some careful looking with magnifying glass, I found this corroded trace here, far away from the battery. I have no clue why it got corroded here, but let's polish it down to the copper and take a better look. Yeah, and as you see, there is connection from the named pin of the CPU socket to this point on the trace, but there is a tiny, almost invisible crack which cuts the trace in two. I think the transceiver can be put back in its place. To solder the trace, I'll put a lot of flux first and then tin the copper as good as I can without shorting anything around. Then just add a thin piece of wire and solder it to the trace. If you have enough flux and solder, then the wire will be pulled straightly by the tension. Well, if the wire is tiny enough. I'm using this method all the time to fix physically damaged traces. Let's do the continuation test. And we have contact. Also to the CPU, as you can hear. Very nice. And again, I add some nail polish to protect this fix. Let's give it another try. I'm using a 16-bit ET4000 graphics card again. And here you go, the card was detected and we have an image. I will add an IDE controller with a compact flash card and Microsoft DOS on it. A small setup in the BIOS. The compact flash card I'm using is 500 megs and there is no floppy connected. And here you go, the mainboard seems to be back to life. It booted DOS just fine. Let's see what sysinfo says. 386DX 40, 16 MB of RAM, seems to be true. What about the benchmark? 43.2 points is quite high for a 40 MHz 386DX. That is actually impressive. By the way, in the introduction videos to this repair marathon, I told that this mainboard has no cache ICs and therefore no cache. Well, in the comments I was pointed to the fact that the Micronix chipset used on this mainboard actually has some built-in cache. And indeed, this mainboard has 8 KB of level 1 cache, which is obviously working at about 30 MB per second. Speeds usual to level 2 cache. It is not too much, but obviously combined with quite fast chipset, it seems to be enough to make all the heavy lifting. Well, I would call it a success. This mainboard is completely working. I didn't spend too much time testing it yet, but so far I didn't notice any issues. The mainboard runs stable and surprisingly fast. I enjoyed this repair very much, and I hope you did as well. Please don't forget to mention your impressions below, and I would be glad to have you on my channel again when I continue this repair marathon. And so far, this is it for today, and I say thank you and goodbye. Wait, and before you switch off, I would once again point to the amazing community-driven Ultimate Hardware 2019 project, a huge database of retro mainboards where you can find manuals, photos, ROM images and more. There, you can search and identify your mainboards now as easy as never before. And if not already included, the boards I am repairing in this repair marathon will eventually all land in the database as well. Also, this Soyo SY-015G is in the database, and I already uploaded the photos and the BIOS ROM image there. A group of people working hard on this project and improve it daily, adding new features, improving, cleaning, and extending the databases. Please support the guys however you can. In the name of the whole retro community, thank you very much for your support.